Hi everyone, welcome to Big Data Spain, and of course welcome to this talk, Multiplatform Solution for Graph Data Source. My name is Javier Dominguez, I'm part of the strategy team, and if you think this is the best place to rest after the lunch, you're wrong. So let's have fun. Let's see what we can do with a big amount of data, a big amount of patience, and Spark. So firstly, I will give you an introduction about the current situation of the big data and our motivation here in this talk. After that, in chapter 2, we will introduce our solution, the environment we have created in the strategy suite, called Multiplatform Solution, and we will introduce the graph use cases we have covered, the data stores, the machine learning we have applied, and in the chapter 3 is the key part in this talk. We will show the data set we have chosen, the main process explanation of the main parts of this talk, and of course, a notebook show-off. I will show you that it's quite easy to create this environment, and of course, a business example, because all these technologies and all this knowledge have been applied in a real bank project. So at the end, I will give some considerations and what's next for this product. As we know, the data, the amount of data we have to deal every year is growing really quickly. We have to deal with customer data that is growing exponentially. So a company that wants to be competitive needs to be able to deal with this big amount of data. We are expected that in the next few years, we will have to deal with petabytes of information. This is the important concept, but it's not the main concept or the key concept in this talk. It's this. The real value is not the data. The real value is understand the data, is know how to extract information from its relationships, extract or convert or transform this information in a high-quality result, and even offer our client a new data that he wasn't expecting. So as an advice, don't stay on the surface of knowledge. Let's study the whole iceberg. Let's extract information from this big amount of data, from this graph database, or whatever. But let's go deeper. So chapter 2 is where we will explain how we have created the solution. What we want to show here is that thanks to a strategy suite that has been designed to cover all the requirements related to the data-centric pattern, we have created a small environment inside it, and now, thanks to it, we are able to, from different data sources, extract information from it, and even offer our client new information, new high-quality information. So this is the summary, what we will see. Firstly, we will select a massive data set. We will transform all this information, all this knowledge in 3 different data stores, GraphX, GraphFrames, and Neo4j. And finally, we will apply machine learning over it. We will extract new information from it. The use cases we have covered in this solution, this environment, are the batch queries. So we are dealing with a massive data set. So we need to be able to create massive queries. So we need to move all this information and extract information from it. So the easier, the better. So that's why we have chosen GraphFrames, because GraphFrames offer us, if you can see in the bottom of the slide, a way to create pattern queries. It's quite easy. You just define the concept, the relationship, and another concept. You can change them, and of course, you can filter the result. We will see it we will see it later. The next use case is online queries. Of course, our client or maybe our teammates will need to have fast and easy access to this information. We are working with a massive data set. So during this time, during the development, we need to offer our teammates a way to access this information, and of course, a way to create microservices and extract information from it. For example, REST services. And even better, if you offer them a way to graphically show this information, it's great. The data stores we have selected are both part of the Spark API. As we know, Spark is a large-scale data processing for distributed work. And GraphX is one of the most famous graph managers inside the Spark API. And this comes with a great variety of graphs, algorithms that we can apply on our data set, like connected components, page rank, triangle counting, SVD, etc. The next data store is GraphFrame. We have selected it because it's really easy to work with it. We just have to deal with data frames. We can create directly this graph. Of course, it offers us the motifs. The motifs are the way how we can create pattern queries over this massive graph database. And finally, the last data store is Neo4j. Neo4j is a NoSQL database, and it's based in two main concepts. The nodes, which stand for a subject, a person, a concept, and the relationships, the arrows between them, which relate these concepts. So, how we can create queries inside Neo4j? We use the Cipher Syntax. Thanks to this Cipher Syntax, we can create pattern queries, and you can see in the right side of the slide how we can create it. Just the node A stands for a concept, likes stands for a relationship, and we chain it with another concept or subject. For example, the node A will stand for Stratio, C for a relationship likes, and B, Neo4j. And this is the way we will create these massive queries in graph frames. Machine learning. So in this point, we know that we need to offer our client another way of more high-quality information, to offer new information he wasn't expecting. But how we can do this? Thanks to machine learning. We can offer him more accurate results and even infer new behavior in our knowledge database. We can fill the gaps of lack of information with predictions. And this is thanks to machine learning and specifically thanks to SVD process. This process will relate all the subjects in our graph and will give you inference of information. We will see this later. And this is how we offer our client this extra information. The third part, the demo. Well, firstly, I want to say that this small environment or this piece of code we have created are built in Stratio Intelligent, which is an analytical environment and is part of the platform as a service of Stratio. The dataset we have chosen is a Google knowledge database stored in Freebase. This database is compressed in RDF method. This method will show the information through a triplet. A triplet is composed by three main components. Subject, which is a resource, what we are describing. The predicate could be a property of this subject, or maybe a relationship with another subject. And finally, the object value is a property of this value or the subject which is related. So every row of the data set will show us a different aspect of the subject we are studying. For example, because I think it is a bit tricky, we can see an example of Cristiano Ronaldo. A property of it could be the number of scores in this year, and the last value is 61. This will be a property of the node. And another row could be Cristiano Ronaldo, born in another subject, which is Portugal. At the end, we have this graph representation, two nodes, two subjects, one relationship, born in, and a property score. And we will transform all this massive database in a graph. The process explanation. This is how we have built this environment, this small environment. Firstly, we have took all the information from every subject. we have recorded and associated all the properties for this subject and all the relationships for everyone. After that, thanks to Spark, we have transformed it in data frames and got the GraphFrame graph. Thanks to the API of GraphFrame, we can cast it or transform the graph in a GraphX graph. Thanks, following the graph, thanks to GraphFrames, we will be able to create this massive batch queries. And in the point of GraphX, now we are able to extract, for example, this is an example in this talk, but we have extracted a small sample of this graph, and we have transformed it in a Neo4j data source. So in just a couple of steps, we have 3 data sources: GraphFrames, GraphX, and Neo4j. And we can offer our client different types of results from every data source. From GraphFrames, massive queries. From GraphX, we can apply machine learning. And from Neo4j, we can create online queries really easy and graphical representation for our teammates or maybe our client. This is explanation of the machine learning process. This is the most tricky part of all the talk, the hardest part. Firstly, we take the graph and we apply a K-core decomposition. I will explain it later. But basically, it's to remove the less important nodes in our graph. We will just keep the most strongly connected graph or the concept which are more related with their environment in that knowledge database. We want to keep just the most important data in our graph. After that, we will transform this information in a matrix. We will relate every subject, and we will give to this relationship a weight, and we will try to infer new information thanks to the SVD process. We will obtain 2 results. In this talk, 2 results. Subject equality, for example, if we want to know who is the subject who is most similar to Cristiano Ronaldo in this knowledge database, we will try to infer who is the sportsman who is most equal to him based on the relationship of this Google Graph database. And we will try to infer the behavior inference. We will try to know more things or possible new relationship for Cristiano Ronaldo. This is the K-core explanation. It's quite easy. Basically, if you see in the right part of the graph, you can see that the less connected nodes are assigned to the layer 1. So the less connected with less connections is the first layer. The second layer are assigned to the nodes with a bit more of connections. If the first layer have 2 connections, the second one will have 3 connections, and so on. So at the end, if you keep advancing in the graph to the core, we will see the most strongly connected concepts, the nodes with more relationships. So what we have done for this example, we have removed the 4 first layers. So at the end, we have just the most strong component, the most strong concept in this graph from Google, just to offer a more accurate result. So, notebook show off. This is the part where we create from the process we have obtained all the information from the RDF compressed data set. We have obtained a data set previously with all this information. And in this notebook, I will show you how we can transform this information in a graph in 2 data stores, GraphFrames and GraphX. Firstly, we can load all the dependencies in this notebook. We load our lovely data set. We can see the scheme of the relationship, the source, the destiny, the type of relation. We load the vertex and this scheme. And to create the graph frame, it's just that. We assign to the builder the 2 data frames. they must have this concrete scheme, ID for the vertex and source and depth for the relationships. And that's how we have obtained the first data source. We can store this information in Hadoop file system, Parquet, the vertex and the edge. And to get the new data source, we can use the APA of the graph frames, and it's as easy as that, to turn the graph in a GraphX graph. And we come back, and we can go from GraphX to GraphFrames, but I think we don't want that. The second piece of code is the massive queries, how we can do it. Firstly, as we did in the first part, we load our graph, composed of data frames. And if you want to check the information of filter directly, just filter in this way. We were searching for Messi, and we have multiple interpretation from Messi in our data set. And let's do better queries. So first, in the first cell, we can see the IDs of Cristiano Ronaldo and Messi. And there are two ways, or maybe more, but two examples of how to obtain data from this graph frame. The first one, the most easy part, is firstly we create our pattern thanks to motifs. In the find gap, we put the node, the relationship, the another node, and we can chain more patterns with a separator. Just easy as that. After that, we filter the information with Cristiano Ronaldo, and we tell him what we want to obtain. Just that. And with an action, in a Spark action, we can obtain the information inside it. Another way is to mix a search from graph frames and use the APA of Spark. We can do whatever we want. For example, an inner join, a SQL search. So firstly, we can search a pattern. For example, the information from the relationship from Messi and Ronaldo, and try to guess the relationship they have in common, the business or whatever they have in common. And we can do it really easy and fast by an inner join of Spark. This is how should look a process in the DEG of Spark. This is the task from a job. And we can see directly in our notebook the information. We can show it, and we will see something like that. Okay. And of course, don't forget to save your information, because it's a pain in the ass if you try to do the same actions again, and you will spend an hour again. Trust me. The next part is how we have created the Neo4j database script generation. Well, the Neo4j. It's quite easy. Basically, firstly, we extracted small pieces, filtering it, of actors, movies, and the role of each one of them from the data set. We have loaded them locally as a text file, and to create a Neo4j database, we just need the batch inserted object to store the vertex and to store the relationship between them. And just that, if you restart your database, you will have our new data or your new Neo4j database. Finally, this is the machine learning part. This is where we have took all the information from our graphene or or graph data frame or graph database, sorry, and we have filtered it thanks to K-core. So the objective of this method is to create 3 matrices. And thanks to this matrix, that each matrix is composed of relationship between the subjects, we'll try to infer new behavior. We'll try to fill the gaps with knowledge. So this notebook is just to create this matrix and try to persist the information. And in the following notebook, we take that information and if you want to know concrete information from Cristiano Ronaldo, for example, we just take the vector of Cristiano Ronaldo, the information of Cristiano Ronaldo, and operate it over the rest of the matrix. And what's the result? What's the inference of this algorithm? This algorithm says that Cristiano Ronaldo will try to be a film actor. It's possible. I see him play. So, what do you think could be the sportman which is more equal to Cristiano Ronaldo in the Google dataset? What do you think? What? Another one? You want to know? Roger Federer. Both of them are sportsmen and businessmen, so it's quite trustful, this. We can see, of course, how he is associated in the data set, like Federer Express, the Mighty Federer, Maestro Federer, etc. So, as we can see, all these techniques, all this information have been applied already. This is a business example. So we had a bank use case where we have to apply these techniques to extract information from the data source. And finally, we have developed a strike-forward functionality to detect patterns in a graph. And of course, give new information from it. They had a problem with the redundant information. So they wanted to find this information and, of course, clusterize it. So the first part, to find this information, we were able to do this thanks to the Jaeger indexation. The Jaeger indexation is a method to compare subgraphs or massive data graph, massive graph frame, and it will return an index. The closer to 0, the more equal they are. And thanks to the connected component method of GraphX, we were able to clusterize all this information. So this is a process which is triggered every day during the last year, and every process is composed by 40 billion of Jaeger indexations and 400,000 clusterization nodes. This is the end of the talk. And just the consideration that thanks to this small environment, extracting that different data source from our graph, massive graph, now we have been able to offer new information. We have offered to our client information he wasn't expecting, like Cristiano Ronaldo data or the similarity with Roger Federer. So we are not in the surface of the iceberg. We are inside it. We're extracting information from its relationship, and we are offered a new product for him. So that's quite interesting, and I think it's the way to work in the future. And what's next? The next steps we want to apply over this piece of code, and for this suite, Stardust suite, include the Elasticsearch. We want to be able to make text search over it. We want to keep extracting more information, more accurate information from it, using connected components, we did with this bank use case, to cluster information, page rank to try to get the measure or to measure the importance of a subject, of a person, a concept, and triangular counting to count these triangular relationships. And finally, now we are able to apply it to new graph use cases like fraud detection, recommendation system, and profiling. So thank you very much for coming. If you have any technical questions, if you want to check the code, if you want to make some experiment, I will be right there waiting for you, and I will answer all you want. And of course, just a reminder that if you love big data and you want to finding new challenge, this is your place. So thank you very much. Thanks for coming. And that's all.
Does anyone have any question? Yeah.
Hi, thanks for the talk. It was very interesting. Could you explain a little bit more about how the find similar people works? Like exactly in the graph DB, how does that work? How does the machine knows that Federer is similar to Cristiano Ronaldo? Thank you.
Yes, basically this is a data science process. We just extract the vector and set to SVD. We will look the similarity between the relationships, and the algorithm will infer that he's the most accurate. So I think it's a quite tricky, quite tricky question. So if you want to come with me, I will show you the code, and it will be more easy to understand. Thank you.
More questions? No? So thank you very much.
Thank you.